Hello everyone, it's a brand new day and welcome to the first episode of Decoded. I'm Vihas Sanchit and today's topic is going to be a data structure called array deques. So, an array deque is a combination of two mechanisms, a queue and a stack. So, as you can see over here, in a queue mechanism, the data is ordered horizontally and the first element that you insert will be the first element that's coming out. And in a stack mechanism, data is ordered vertically and the last element that you insert will be the first element that's going to come out. So, as I said earlier, the array deque combines these two mechanisms into a dynamic array where you can insert from both sides and also take out data from both sides of the array. So now, let's discuss some key features of array deques. The first feature is double-ended access, which means that, as I said earlier, an array deque can be accessed from both the sides, the front and the back, to insert and also take out data. This makes it very flexible. Next, an array deque is array-based, so access to data will be very fast because the elements are stored next to each other in the memory. The next feature is that there is no capacity limit. When the amount of data inserted into the array grows, the array will also grow with the data. The next feature is memory efficiency. Array deques use much less memory, unlike linked lists that have specific allocations made for node pointers in handling data. So that will be all for the features, and now let's discuss an example of how array deques can be used in real life. So as you can see over here, you can see an image of people getting into a bus. So you can consider the people as elements and the bus as the array. So when you consider this bus scenario, both the doors can be used to enter and exit by the people. So this makes the process very efficient rather than using one door for one task. That would make it very inefficient and very troublesome for the passengers. So now let us go see how array deques really work through a code segment. Now I will be showing you a few code segments over here that operate on an array deque. After that, I will be explaining to you about how they work. Then I will show you our array deque and how these commands that I have shown you have caused changes to it. Okay, so here you can see Deque. The Deque is a variable that I have used to show deque. Now, in the first part, we have used deque.append_a, which means that to the array deque, we will be adding a from the rear towards the front. So now there will be one element. So by the second step, deque.append_b, we are adding another element b right after a. So from the rear towards the front, we have added a and then b. And by the third step, deque.append_c, we are going to be adding another element c right after b. So when we print that array part deque, we can see that we have a, b and c. So now by the fourth part, we have deque.append_left_d. Now this is a bit different. We are going to be adding d right before a. So now we are going to be inserting from the front side. So when we print this stage, we can see D, A, B and C. So now we are going to move to the fifth part, which says deque.append_left_e. Now, just like with the D, we are going to add another element from the front side. So that makes it E, D, A, B and C. So now we have an array deque with 5 elements. So by the sixth step, deque.pop, which means we are going to be pulling one element out from the rear. So the element C is going to go out. Then we are going to have E, D, A and B. So then by the 7th step, we are going to be using the code deque.pop_left. So with this pop statement, specifically pop left, I am going to take out the element that is towards the front side and I am going to take it out, and that element is going to be E. So when we print the final statement deque, we are going to be left with D, A and B, which means that we have now popped the E and the C out of our array, where now only 3 elements are remaining. Now in this image over here, you can see that our array deck has changed significantly after our previous code segments that I have explained. So first you can see that we have inserted A from the rear and then B and C from the rear. After that we have inserted D and E from the front, which makes it so that we have 5 elements within our array deck. So after that I have popped C out from the rear and then we have popped E out from the front, which makes it so that now only 3 elements D, A and B are remaining within our array deck. So this is how our array deck has changed based on what happened within the code segments that I have explained previously. Now we are going to talk about the advantages and disadvantages of using array decks. So as for the advantages, array decks have no size restrictions, and also an array deck can work as both a queue and a stack, so that you don't have to use different structures if you need to use either of them. And also an array deck is faster and much more memory efficient when it comes to actual performance than linked lists. So if we look at the disadvantages, you can't directly access the middle elements like you can in a list when you are using an array deck. And also, when the internal array becomes full, the deck needs to double its size, which requires copying all the elements from the first one to the latest one. So this means that it's going to take a little bit of time. And also, if you're using Java, the array deck cannot store null elements. This is because in Java, it is used to internally mark empty spots. So up to now, we have discussed about what an array deck is, how it operates, its main features, and even a practical example. We have also discussed a code segment and also the advantages and disadvantages of this data structure. So by now, you must know all that there is to know about the basics of this data structure, which is the array deck. So I think that will be the end for today's video. Make sure to subscribe to my channel if you haven't already. Like this video and stay tuned for my next video.